Hello everyone. I'm Andy, a lecturer at ThinkMo. Currently, I'm teaching CCIE course. Starting today, I will share with you some CCNA, CCNP, CCIE related technologies. Our topic today is: what problem does eTrunk solve? Before explaining eTrunk, let's first recall the F-trunk. We've covered it in our previous videos. F-trunk is called chain record aggregation. We also call it LAG. What F-trunk solves is link utilization issues, improve link reliability, including load sharing we mentioned, increase link bandwidth. Its experimental way is simple. Is the physical ports bundled as logical? Form a logical link. So what is eTrunk? It's called cross-device link aggregation. So what is link aggregation across devices? This also starts with F-trunk. Let's look at this picture. This is a model of F-trunk. There are two wires on the CE device. There are also two lines on the PE device. I put these two lines on the CE device. Connect to the two wires on the PE device. We can also understand that. Connect the two ports above the CE. Bundled together to form a logical port. The same is true on PE devices. Because F-trunk is bidirectional. Do both ends. May cause a problem in the process, such as when a device fails, or power outage, or connect this device. Physical port after a failure. The data in the CE direction will not be forwarded. Based on this situation, equipment failure is unavoidable. Although it can link-based redundancy, but there is no device-based redundancy. Then for cross-device circuit aggregation, eTrunk is the F-trunk link reliability from the board level to the device level. This is a problem it solves. How to improve from the board level to the device level? There was a device. Now I have two devices. I put these two devices all connected to CE. After connecting, the line is still connected to two lines. But for CE equipment, the eTrunk is not visible. For CE, equivalent to 4 lines connected to PE. To be precise, P1 plus P2. Then it can put these 4 lines, bundle up and make LAG. That is the link aggregation we mentioned. For PE, inside are two devices. Externally is a device. In this situation, P1 and P2. What can be done? Two lines of P1 do link aggregation. Tie it up. The two wires from P2 also tie it up. Then in the process, what is the internal role of P1 and P2? Any of them can be the master device. It can also be a spare device. This depends on the specific configuration. Normally only the main device works. Standby equipment is not working. When the master device hangs up, the standby device will take over the work of the main device. That is to say, for the CE side, although I see a device, but normally only one direction of the circuit can be used. But in F-trunk, after a device fails, another device cannot take over the job. It's okay for eTrunk. So eTrunk is equivalent to F-trunk extension. We call it cross-device link aggregation. But strictly speaking, this is not rigorous, because it cannot be achieved. Two devices work at the same time. So the eTrunk is solved. Link reliability from the board level to the device level. The third aspect, how we use eTrunk. Need to pay attention to the following aspects. First, for CE, we need to put 4 lines Bundle up first to make an ETH trunk. For example, in this picture. Created ETH trunk 20. Then connect these 4 ports. Join ETH trunk 20. Then connect the ports of the P1 and P2 devices. Added to ETH trunk 10. The same direction. This completes the first step. The second step in PE equipment. Create the same E-trunk. Third step. Configure heartbeat detection for E-trunk. Everyone can see. On both devices P1 and P2. There is a dotted line in the middle. This dotted line is the heartbeat line. It is used to detect the primary and secondary devices. During this process, P1 and P2 will send each other UDP-based messages. Since we mentioned UDP, everyone should know. This line is a 3-layer line. Since the 3-layer line is involved, we're going to have ports on P1 and P2. Configure IP address to communicate between them. Then the message can be sent and perform active standby detection. Under normal circumstances, PE1 is the main. ETH trunk 10 of PE1 is the main. The link status is up. PE2 as backup. ETH trunk 10 of PE2 as backup. The link status is down. When the master device hangs up, the standby device cannot receive the message. Because the main device hangs up, can't send messages anymore. At this time, P2 is converted to master device to take over the job. That is to say, for CE equipment, it can only send data in one direction. 2 devices cannot forward data at the same time. Under normal conditions, data can only be sent in the P1 direction. When the device hangs up, the line here cannot forward data. Now the ETH trunk is invalid. At this point the data will be P2 starts sending. So how does P2 improve? What about the main device? It is through the middle. This line to achieve the detection of. The fourth step is to put the PE device on the created ETH trunk binding with E-trunk. If the link between CE and PE1 fails, PE1 will send E-trunk packets to the peer end. ETH trunk 10 of PE1 is carried in the packet. Fault information. After PE2 receives the E-trunk packet, found that the peer ETH trunk 10 is faulty. Then on the PE2 device, the status of ETH trunk 10 will become master. This concludes our sharing today. If you have any other techniques you would like to learn, welcome to leave a message or private message me. If you are interested in what I have to say, hope to like, share and subscribe. See you next time.